just to make sure you're on the right track. So these sections on the review are the exact sections that are going to be on the test. The first thing we have to remember, evaluating a function, all right? A couple of things, parts of the function notation. Your G sub whatever, F or H, whatever, that still means Y, okay? So when I ask students to evaluate a function, I went and highlighted. Let's kind of start on the review. You need to remember this fact. Function notation, like if I have f of a -3, that means the -3 is your input and you plug it into your x for x. So if you want to highlight this, you can memorize this so you can apply it on the test. The function notation, when the number's inside the parentheses, it means that is your input and you will plug it in for x. If the number's outside, like if you have x in the parentheses in the number and it equals the number, so f of x equals 3 here means that your whole function is equal to -3, and you're plugging that in for y. That's what I'm trying. So you're trying to find, that is the y. You're trying to find the x. When it's outside, yes. So when we evaluate, we're plugging in. So let me just fix my font real quick. Like this is basically saying -3 parentheses plus 1. You're going to plug in the number, put it inside the parentheses. Whatever number is given to you in the function notation. This one, because there's an x squared, that's parentheses squared plus 7. This would be 12 over parentheses. And here we would have 2 parentheses, then plus 9. So we're still going to plug it in, but then we're going to just simplify it. Use the distributive property on 6. I'm going to get to that one. So like if we're showing the work to number 1. Whoa. Sorry. Let me reconnect real quick. You're going to do 3 parentheses. Okay. I think it's connected now. So this is saying 3 parentheses plus 1. And what we're plugging into the parentheses is that 10. So we're just, it's -3 too, sorry. So we're just doing order of operations from here. -3 times 10 is a -30. Plus 1, you get -29. So function notation, since the g sub x is same as y, okay, our output is a -29. The 10 was the x. So this would be the order pair 10, -29. I refer to the order pair because you're going to have to find that on the graph. So like there's going to be some graphs. This is just evaluating, getting the output, solving. So for h of a -2 here, this would actually end up being 12 over -2, which simplifies to just a -6. Now, if you have, let's say you don't have numbers, you have letters, variables, still plug it in. So like even with number 5 here, h of a, that means 12 over a. And that is the simplified answer. Can't do anything else to that.
For number 3, for the ordered pair would be 2.
Comma, yeah, the order pair would be -2, -6. Now, for 6 here, see this is g sub and b plus c is inside the parentheses. This is representing my x. My g function, my g sub x, was at -3 parentheses plus 1. So what I'm plugging in to the parentheses is the expression b plus c, yeah. Then to simplify it, okay, we're going to distribute the -3. So this would be -3b minus 3c plus 1. And that is our output. That's the final answer. Okay. All right. So then I'm going to ask you to use a table with the function. So there's not really math here. It's just understanding the parts of the table.
What about number 10? -1 just have its
Number 10. Okay, so, okay, hold up. Remember, x's are inputs, right? And then f of x, that's our output. Are we okay on that part? Meaning, just remember, your f of x is like your y. These are your y values. Okay, so for 10, well,
it's not in the table.
it's not in the table exactly because this represents the x. In the x row up here, there's no -1. So if it's not in the table, the answer we write is unknown. Or you can say none. Or does not exist. Okay? We can't pull out a number that's not even on the table. No, it wouldn't be 0 because there is no -1 as x's.
Oh, okay, in the x.
Yeah, yeah. So like here, because all of these are x's. So this function, the f of -3, should equal 2. There we go. If I was doing f of 8, that should equal 4. So because I find the 8 on the x-axis, there it is. It maps to 4. Now, on the next row, 11 through 13, they're asking you if the function is equal to 9. So the 9 that it equals, this right here is the output.
So this we're supposed to find the x.
Yes, you're trying to find the x. Yes, so in this one, because what is the x? This would be x equals 2.
Here's for like 12 where it has like both is 4. You put 8 comma 9 or like 9 comma 8.
Yeah, because there's 2 answers.
There's 2 4s.
Right, so there's 2 x's, 2 answers.
2 answers.
Yes, x equals 9 and x equals 8. All right, what about 13?
X equals 20.
Yeah. Okay, x equals 20. All right, so just reading it off the table. Not much math on that, okay?
Oh, I get it. No,
All right, so then on here, they want you to find the x when given the function. Okay, so if they give you the function, there's 2 methods. I'm going to show you 2 methods. So the first method, you're going to plug in the value of y to write the equation and then solve for x. Because they want us to find x, so we have to solve for x. So if you look on 15, the h of x equals 12x over x. If h of x equals a -2, remember, this is like a y. This is our output. I'm going to plug this number back into the function to write the equation. I'm not plugging it in for x. I'm plugging it in for the y. So the equation here would be -2 equals 12 over x. So to solve this, who recalls maybe the method we should use to solve? Because we have a constant over a variable. Ayo. Multiply by the reciprocal. Which reciprocal? The reciprocal of 12? There's a faster way. See how we have a ratio here? Huh?
What's going on? To multiply. Oh,
Make 2 ratios. No, make 2 ratios so that you can cross multiply. Yes. So that's 12 and that's -2x. Then to solve, you're dividing by the coefficient. So dividing by -2, -2. Our x equals -6. Yes. If you use the reciprocal of, and you multiply x over 12, because that's the reciprocal. When you do that, if you multiply it by x over 12, it's going to cancel both things. I'll go over and see what you did. Just give me a second.
I get it.
Uh-huh. Okay, so try number 14. See if you can plug in the value.
I already did them.
Okay. Okay. So basically here, our g sub x equals the 16, and I'm plugging that back in. So 16.
The question are going to be like this if you're trying to do that.
Yeah, you're going to have to plug it back in. And then to write the equation so you can find the x. Yes. Now, there is a shortcut. There is a faster way. Instead of plugging in and solving an equation, that's method 2 that I was going to remind you of. Okay. I'll put that on 16 and 17 just to address it. Okay, so you could just use your calculator. So you would have to use the y equals. Plug it into y equals in the calculator. So like you put the function, the equation for the function. So like since this is, I would write this as y equals x squared plus 7. Y equals 2x plus 9. So you have to go to y equals, type in the equation. So like if I'm doing the number 16, since we have x squared, just trying to recap, x, and then you square it is the number over here by 7. And then we have plus 7, right? Now you have to go to the table. Do y'all remember how to get to the table? All right, second graph gets to your table. We have the output, meaning we have the y values. Okay. You go to y equals, you type in x squared plus 7. I'm doing number 16. 530. Okay, hold on. Then you go second graph. What are y'all doing? Are y'all going down to 23? No. The 23 is the output. It's the y value. So look, that's why I highlighted the y's. Because we're going down to where I see 23. There's the 23. So, because we're finding the x, guys. Remember? We're finding the x. Yeah, so it's 4, exactly. Very good. Okay. Make sure you're looking at the correct column. Okay. So this one, our x would equal 4. Okay. Now, depending on your table, I want to just talk about it. Because
you just square root it.
Yeah, you take the square root.
Yeah, you put second and there's a square right there. You can square it. You're solve it the other way. Solve it.
To solve it, I don't use a calculator. You still plug in. This plugs in, right? So we have 23 equals x squared plus 7. We subtract the 7. Okay. If you subtract 7, that's going to leave you 16 equals x squared. Then you take the square root. Okay. So there's actually 2 answers here. X equals 4 and x equals negative 4.
How do you find the square root?
Second x squared. Like you do second, you hit the second button and then you hit the x squared button.
It's still just like the same answer for both because if you square negative numbers are possible.
Okay, so
Wait,
What?
So x equals 4 and x equals -4.
Yes.
Both of them, x because if you square negative.
Yes. Yeah. Hmm.
So you're so smart.
I will give you credit. Yeah, because we haven't talked about quadratics yet. So yes, you'll be fine. You'll be fine with either or. Okay.
Oh no, it's I think it's like
So
it's like -4 times -4 is still 6.
that's right.
Because it's still two negatives.
So on finding the x on 17, okay, did anyone, if we plug it back in,
X equals 18.
yeah, the answer is 18. This is if you're using method 1. If you use your calculator and look at the table, the answer x is equal to 18. All right, so you are definitely going to be given functions as equations and asked to complete a table and to plot the values on the table. Okay, I'm going to start with 19 real quick. Okay, just so because it reviews fractions again. So our function on 19 is y equals 3 over 2x, or 3/2 x minus 1. So I'm going to show you another thing, a new little trick as well. So if you go to y equals, we're going to clear this out. We're going to put 3/2 x. Alpha y equals, enter gives us the fraction box. I'll do that again. Alpha y equals, and then enter gives you your fraction box. The 3 goes on top, 2 goes on bottom, arrow to the right to put your x. And then we're going to have minus 1. Isn't it minus 1 or is it plus 1?
Minus 1.
Yeah, okay. All right, so then we're going to go second graph to our table. We need to complete the values for -2, so I have to actually arrow up to get to that -2 answer. And then we want 0, and then a +2, right? So we can just copy in our values here. We should have our domain here, our range here was -4,
-1,
-1,
2,
2, and 5, okay? Now we're going to just plot those points on the graph. So remember, the horizontal line is your x-axis. The vertical line is your y-axis. We start at the origin. A -2, -4 means you're going to move to the left 2 and down 4. Plot that point. 0, -1 means we're staying on the y-axis and just go down 1. Then 2, 2 means to the right 2, up 2. And then 4, 5. It's right there. All right, so you use your straight edge to draw a line. Sorry, I didn't mean to do that. Through those points, right? Okay. Now, 2 things, guys. If I wanted to check my graph, if I just hit the graph button, I can see if my line matches what I graphed. Okay, that's another way to problem solve. Okay, here's what I want to show you. Right now, this is full screen with just the graph. I'm going to show you how you can put the table and the graph on the calculator screen at the same time. So to do that, you have to hit the mode button. The mode button is next to the blue second. I need you to do that for me. And this is what you should see. Get to your mode, okay? Now, you need to come down to the line where it says full, because that means full screen. We're going to select graph table. So if you arrow to the right and highlight where you see graph table and just hit enter to select it.
G-T.
Yeah, G-T. Is that what it says on y'all?
I'm pressing enter, but it's not working.
Yeah, once you press enter, it just highlights it. Like even once I go down, it should stay highlighted. That's all it does. It selects it. Yeah, and now when you go to graph, we have the graph and the table. Huh? No, just hit the graph button. Just hit graph. Yeah. Okay, now, let me just show you something real quick, okay? All right, so if I want to go up and down my table like we normally do, you still have to hit second graph to get that cursor in that table box. Okay, notice this right now. Look, you see how this is highlighted -2, and then right there they put the point where that is located on the graph. So even as I scroll down, it's gonna go to that point on the graph. It's gonna show it on the table, and you're gonna see a little X on the graph where that point is located. Does that make sense? Okay. So like when you're doing your tables and your graph, you can do them at the same time if you're in that mode. Okay. All right. So if you haven't done so, please finish 18, because I know some of you don't have the graphing calculator, even though there's also a free app version on your phone. Okay. And then we're going to go to the next section. Or not the next section, next problem. So in evaluating or reading functions as equations, I will either give you the table and the graph, or I'll give it in a sentence here, in a set. This on 21, find the range of the function y equals -x squared minus 3x when the domain is -5, 0, 2. So domain is your x. So this means these right here are x values. So if you want to, you can create a table. First column is always your x, and you can put these numbers in the table and then go to your graphic calculator to get the outputs of those numbers. So we have to put this function, this equation, in the calculator. So we go to y equals, I'm going to clear this one out, -x squared minus 3x, and then I can go to my graph. I see both. But we're looking for -5, so I have to go second graph and arrow up to get to that -5. Okay, since we have -5, I think it was 0 and 2. That means we're going to get -10, 0, and -10. As the set for our range, we use the braces to show that set of numbers.
You do this without a calculator?
Yeah, you would have to plug in each number. Yeah, yeah. So you would plug in the -5 for each x and get the output. Then you would do the 0, which is 0, and then you would do the 2. All right. Okay, so the remaining of your review is really analyzing graphs. Okay, function notation with graphs. So on 23 here, first make sure you see that the graph, the function is actually this U shape, the solid view. It's called a parabola. It's part of a, so it's the graph of a quadratic. Okay, now when we're asking to find the output, here they want f of -2. This -2, what does this represent?
X.
Yeah, so then we have to find the y. So we're on the x-axis. Oh, they already had that. So on this x-axis here, go to -2, which is right here, but go up. Oh, I went too far. Sorry. -2 is here. Yeah. So this is the origin right here. Left 2, and then go up and stop where it touches. So how far up? Because that's the y. So this would be 4. Yeah. So then, yeah, 2 is going to be 4 also. So then for -1, that's just to the left one, go up. That output is 1. For 0, that's it stays on the origin, so 0. Okay. So 2, we're going to the right 2, go up. So, because these are representing, remember, 2, 4, These are the order pair. The 4 is your output. Because, guys, don't forget, your f of x, remember, it just means y. And your order pair are x and y. Which could be said as x and f of x. They mean the same thing. All of those mean the same thing. Okay? Diego? Right after this section. Hold on. All right, now, 25. You're going output and input. Look at 25. Fill in the missing information using the graph to the right. So, on f of 2, since 2 is the x, go to... Yep, that answer, that output is 12. Yes. But now, f of some number gives you 3. The 3 is the y, guys.
Is that 0.5?
Yeah, that would be 0.5. 0.5. Because you got to go back down to find the x. Okay. All right. What about when it's 3.5? That.
18.
Yeah. 18.
1.5.
1.5 for the last one.
Yeah. 1.5. There we go. Okay. All right. So then we're looking at the last section is relations, functions, domain versus range. Domain and range. So I do want to address this again because I'm going to pass back the worksheet y'all did yesterday when I stepped out. And we're still having some minor hiccups with domain and range and how to write it. And we had some of you skip a lot of problems. So we got to finish in classwork in class. Got to be disciplined, okay? So first thing, we're going to use inequality notation. Because they want you to use inequality notation, that means it's going to be a less than or less than or equal to. We're going to use that to write the domain. Domain is when we're using our x's, and our range is when we're using the y in our inequality. So when we're finding the domain and range on a graph, we have to scan the graph for domain. You're going to go left. Oh, I meant to do that blue. Sorry. Left to right. I'm just a L to R. Okay, so the graph on here, guys, actually is this kind of upside down V. That's the actual function. Okay, it's that solid V upside down. So the left of the graph is over here, but do you see how it's pointing down? That means it's going to keep going in that direction, which means it's going to keep going out.
So negative infinity.
Yes, negative infinity.
At the end.
Yeah, so for the right, it's also going to be a positive infinity. So whenever only the domain is, Timmy, not the range on this problem. So
I mean, like, is both of the domains like left to right?
yeah, always scan from left to right because you're scanning the x-axis.
How would you do the bottom?
So negative infinity is less than x.
So what if you just put the symbol?
Right, that's what I was trying to get to. If I see negative infinity to positive infinity,
It's not negative infinity?
it's negative infinity. I did put a negative infinity.
No, the other one.
This way it's positive. These are positive numbers.
Oh, I was looking at the y-axis.
Yes, anytime we have negative infinity, this is your answer right here. All real numbers. Negative infinity to positive infinity. It's all real numbers.
So if you don't put that, if you don't put like the inequality.
No, this is the answer. The inequalities hope to get you to the answer. Okay.
But if you just put all real numbers, you'll still count it?
That's the answer though. Okay. So range.
Is it y less than 0?
Yes, because we're looking the bottom to the top. Both bottoms here are pointing down. Since they're pointing down, that's a negative infinity. The top, you have to look at the y-axis. The top of the graph is at 0. So it's starting at 0 and everything gets pointed down.
Let's say the peak was at 2 on the y-axis. Like it was at 2 up, more up, right? We would look at the y because the range is y.
Yeah, you always look at the y for range. I don't care if the point is on the x-axis. You have to look at the y value. All right, so this is y is less than or equal to 0.
less than or equal to?
Yes.
How do you know this?
Yeah, I always ask this.
Oh, what?
How do I know when it's a line underneath the inequality
Yeah.
versus not?
Because it has no, but this has no dot, so either way.
Yeah. Anything with a solid line is going to be less equal to.
And we
Oh.
started with the y because normal is a y.
Yes, you start with the, yes.
Is it a
Uh-huh.
So let's say the circle, right? If it has like an open, that's when it's gonna be.
Yes. Yeah.
So when you get that.
If I go from least to greatest, then yeah, it's always less than. If I start with the smallest number to the biggest number, it's least to greatest, so less than.
So,
Okay.
so just put a negative and y.
Yeah, we don't put a negative thing. We just put y. Yes. Mhm.
You only have to put infinity when it's both.
When it's both. Yes. Yeah. All right. Function. Determine if my upside down v is a function. To
Is it a function?
Yeah.
yeah. To do that, you do the vertical line test. Look, you just draw a vertical line. Does this vertical line touch the v one time? Yes. So this is yes.
You can do the vertical line anywhere in the graph, right?
Anywhere on the graph, yes. As long as it touches once, it's a function. If it touches more than once, it's not a function. That means it's repeating an x. Okay? So on 27, this is mapping notation. It's different from a graph. Your domain are your x values. So look at your x circle right here. So our domain would just be the numbers in that circle. 0, 4, 9.
No.
For our range, that's our y values. Y circle is 2, 3, 4, and 5. All right. Timmy, why is this not a function?
Because there's two nines.
Oh.
Yes, the 9 splits out and repeats. We have 9, 4, and 9, 5. So basically, anytime you see this split, guys, this proves not a function. I'm just going to abbreviate that. Anytime I see a split out of the mapping notation, it proves not a function.
Is it repeat? Yeah, definitely repeats.
Okay, so 29, guys. Look at 29 with me. The graph of the function is actually this pentagon. Okay, it's a solid line, so it's equal to. I'm doing the domain. I'm scanning from left to right. Here's the left of the graph. On the x-axis, that's at a -3. Here's the right of the graph. On the x-axis, that's at a +3. So it's -3 is less than or equal to x, which is less than or equal to +3.
Wow.
Now, to do the range, we're going to scan the bottom to the top of the graph.
Is it -1
Yeah, the bottom right here. Remember, we're looking at the y-axis. Here's the bottom at that -4. Okay? So I'm going to fix that real quick. The bottom here is at -4. The top is at 3. Yes. The range is in between here. So -4 is less than or equal to y, which is less than or equal to 3. All right. Is this a function?
No.
No, because when I draw a vertical line,
It touches twice.
it touches twice, right here and right there. So no.
Omega p is a function.
B is not a function at all. Look, if I draw a vertical line on B, it touches everywhere. Okay.
Well, neither is.
Yes.
Mm-hmm. All right, on the back, guys.
That wasn't like so as soon as
All right, next page, real quick.
Oh,
31.
I'll look at you glasses.
All right, this is just set notation instead of order pair. So out of the order pair, you want to make sure you can give me the domain. That means we're looking at only the x coordinates. So make your brace. This should be 10, -2, 5, and 4 for the domain. For the range, we're just giving the y coordinates.
ah,
So that's your second one.
7, 4, 3, 10.
Yep, 7, 4, 3, and 10. Done. Now, what's the value of the function f of 10? Yep, the answer is 7.
easy.
Okay.
Did you get me?
Let's look at 33. Now, I know there's some opens, but make sure. Yeah, sorry, did you have a question? Yeah. Go ahead. I know there's opens, but still make sure we're looking at the correct part where the open is. Like, the open here is with the x-axis, the left, okay, to the right. I gotta look back up at the x. So the domain here should be -2 is just less than x, which is less than 2.
For the range, what would be bottom?
The bottom would be over here, but you're looking at the y, remember? You always have to look at the y for the range.
Would that be a 5?
-4. Sorry. Okay. And this is the top, but you have to look at the y-axis.
And that would be closed, right?
Yeah, because it's a solid line right there.
Oh.
So this is -4. It's less than or equal to y. It's less than or equal to 0.
Why is it less than or equal to?
Because
You just said it.
it stops at the top of it stops at 0.
Oh, yeah.
Because the circles are open. That's why.
But it's only open for the x's. Yeah, Timmy, right here at the top, the line is solid. Okay.
Talking about the
Yeah, this is yes, it is a function. Okay. Okay, so we're gonna look at some multiple choice type questions because this is kind of like how you'll see it on the test. So on 35 here, it says, what is the range of the relationship below? Because I have the keyword range, right? Which means what, basically? Y, okay? So range means Y. So right off the bat, I should eliminate some answer choices. Yeah, because A has an X in it and C has an X in it. Now I'm down to 50-50. Remember, range is bottom to the top, but you're looking at the Y axis.
No.
Why is 6?
It's 6. It's 6. That dot doesn't matter. It's
Yeah,
top, so.
sorry. Sorry. Yeah, this point doesn't matter. Like, this doesn't matter. What matters is the Y. You have to look at the y-axis, and then
Every time it's like that, shut up.
No, the dot's for the X, not the Y. The open is for the X, not the Y.
Oh, because that's left and right.
yeah. Okay, so on the back here, guys, here's some good sample test questions, also sample EOC questions. So try your best on this. Okay.
Are you done?
And tonight I'm going to post the partial key on Teams and some flashcards to help you study. You just got to go there.
Whoa.